Welcome to Algebra 2. This is our first chapter. Our first chapter is on recursive sequences. So in this video, I hope to give you an idea of what is the basic idea of what a recursive sequence is, give you a lot of the vocabulary that we're going to be using heavily in this chapter, as well as throughout the whole course. A lot of algebra has to do with recognizing patterns, with describing patterns, and we describe patterns usually with the language of math, which looks like equations, and then we use these equations to solve our problems. But before we can even begin to work at solving these equations, to solving these problems, we have to first start looking at how do we find those. One of the easiest ways to recognize and start writing these equations is to start looking for some of these patterns that rely on this idea of recursion. Recursion is basically the idea of using the past to figure out what's going to happen in the future. When we do a process recursively, we are always using our previous answer as part of the problem to find the next step. So we're always using what went on before to find the next one. So, for example, let's look at a simple pattern here. I'm going to draw some triangles. So we start with one triangle. We needed 3 lines to draw it. So we've got triangles and lines. Now, I can make that into 2 triangles by adding 2 more lines onto there. So with 5 lines, I have 2 triangles. If I add another 2 lines here, now I have 3 triangles. Add another 2 lines here, 9 lines, I have 4 triangles. As you see, I'm doing the same thing over and over again. I'm using the figure I had before, and I'm adding to it. And in this case, each time I'm adding 2 more lines. And if I add 2 more lines, I get another triangle. So now I have 11 lines to make my 5 triangle. This is a recursive process, because I'm using the last number, I'm using what happened before to figure out what's going to happen next. I added 2, I added 2, I added 2, I added 2. I could keep on with this process forever. And I will always find my next number by just adding 2 to the number I had before. Or I can get my next picture by drawing in 2 more lines. That's this idea of recursion. It's something that you're familiar with. It's something that you've done before. You pretty much have worked with these idea of here's a number pattern, figure out what's going on and find those next numbers. That's what we're looking at with this idea of recursion. That brings us to the idea of a sequence. A sequence basically is a list of numbers. But what we have to be careful of is the list has a specific order. If you move the numbers around, it is no longer the same sequence. It may be the same list of numbers, but if we mess up the order, it is not the same sequence. So our order matters, and when we start describing this, so the vocabulary we're going to talk about is going to involve the order as well as the number. So we'll start with our sequence we developed here, and this starts with 3, then 5, then 7, then 9, then 11. And then I'm going to put my 3 little dots here to say this is a pattern that will go on forever. You can't have sequences that stop, but generally when we're looking at these sequences, they are going to go on forever. Now, as we start referring to this, we're going to give it a name. So I'm going to call this sequence U. And U is not really, sacred for dealing with sequences. We use U in this class because as we use the graphing calculators, U is a variable that it likes to use for sequences a lot. So we'll be using U to represent that. Now, as we said, it matters, well, we got these numbers in here. So each one of these numbers, we'll take this 5. This is what's called a term. And a term is just one of the numbers in the sequence. But we say the order is important, so we got to know where in the sequence that occurred. So this is the first number, 3 is the first number, 5 is the second number. So 5 is the second term. And I'm going to represent it by U, saying it comes from my sequence U, and I'm going to put a subscript of a 2 there. That means it's the second term in my sequence U. So if we wanted to say, look at 11, 11 again would be the sequence U, but in this case it's going to be, see, first, second, third, fourth, fifth, the fifth number. Oops, I need to do that. So we can talk about specific terms on here by putting a subscript on saying which number in that list is it. And that's, again, that idea that we need a defined order. That order makes it really important. So when we don't know what order, what term it is, where it rides in the sequence, we want it a little bit more general. We make n be the subscript. And this makes this is going to be the general term. When we say U sub n, we're saying I got a sequence, U, and it occurs somewhere in that sequence. I don't know where it is. But this is where we talk about this more general term. We describe these recursive sequences with a recursive formula, which I have written down for our sequence right here. It starts off U sub 1 equals 3. U sub n equals U sub n minus 1 plus 2. Now when we write one of these recursive formulas, we will always have 2 parts. And I'll start with the second part. This is the recursive rule. And this is just what do I do to find the next term. And as we look at here, U sub n, that's our general term. That's going to be what comes next. This U sub n minus 1, this is the last term. So we're saying take the last number we had and add 2 to it to find the next number. And that's our recursive rule. And that's that important part to show that recursion. What's the pattern? That's what's being described with that U sub n. But we also need this U sub 1 equals 3. This is what we're going to call the starting term. If you don't know where you start, you can't add anything onto it. And that's the one thing with this recursive routine, or recursive formula. We're using the previous number to find the next one. If we don't have the previous number, we can't find the next number. So when we write one of these recursive formulas, we must have both parts, both a starting point and a recursive rule, which helps us find any point along the way. Let's look at a couple examples. Example 1 says U sub 1 equals 14, U sub n equals U sub n minus 1 minus 3. So if I were to write out this sequence, I would start off with 14. That's my first number. To find my next number, I'm going to take my previous number and subtract 3. So I take 14 minus 3 and I get 11. To find my next number, I take my previous number minus 3, so 11 minus 3 is 8. And 8 minus 3 is 5, and I can keep going on from there. In my second example, I have U sub 1 equals 3, U sub n equals 2 times U sub n minus 1. So in this case, again, I start off with my starting number, 3. But to find my next number, I take my previous number and I multiply it times 2. So 3 times 2 is 6. 6 times 2 is 12. 12 times 2 is 24. And we can go on from there. While there are a lot of different types of sequences, and not all of them are recursive, the two we are going to focus on in this class, and especially in this chapter, are the arithmetic sequence, of which example 1 is an example of, and the geometric sequence, which we see in example 2. The arithmetic sequence is one in which we are a simple recursive formula where we will be adding the same thing each time. The geometric sequence is, again, a simple recursive sequence where we're going to multiply each time. And I encourage you, think about it as adding and multiplying. Don't worry about subtracting or dividing. We'll add a negative number, we'll multiply by a fraction. But we will always think about adding for arithmetic and subtracting for geometric. When we talk about an arithmetic sequence, we talk about something we call the common difference. In this case, my common difference is -3. It's the number that we're adding each time. We call it a difference because we get this by subtraction. To find the common difference, we take our current number and we subtract our previous. And as we say, it should be a common difference, means we get the same answer for each case. So if I take 11 minus 14, I get -3. If I take 8 minus 11, I get -3. If I take 5 minus 8, I get -3. If I have that common difference, if I cannot take any number in my sequence and subtract the number that comes before it and always get the same answer, that's my common difference, and I have an arithmetic sequence. And I'm adding that common difference to each new term, each previous term, to get the next. To summarize, the recursive sequences we are going to be looking at will be either arithmetic or geometric. In an arithmetic sequence, we are going to always be adding the same number. That's called the common difference D. We get that by taking the current number of the sequence minus the previous. It should always be the same number. And your sequence is going to look like U sub 1 equals A, U sub n equals U sub n minus 1 plus D, where A is that first term, that starting value, and D is the common difference. For a geometric sequence, we're always multiplying by the same number each time. That's that common ratio. We get that common ratio by taking the current value divided by the previous. So a geometric sequence will have the formula U sub 1 equals A and U sub n equals R times U sub n minus 1. Now just two little things to close. Don't get too hung up on what letters we're using, A, D, R. As we go through, we're going to use different letters at different times, depending on what we're doing. But keep thinking about that basic idea. Am I adding the same thing each time? Am I multiplying by the same thing each time? The other thing to be careful of is our starting value. We've been using U sub 1 as our starting value because we're just looking at a list of numbers, and you always start a list with the first number. But depending on your situation, we may have something else for the starting term. The most common one we will use is U sub 0, as you look a little later on in this chapter. But be careful, you do need to consider what are we calling our starting term, because it's not always going to be a 1.